Okay, well, good afternoon. Welcome to the Fluency versus Automaticity, What Should We Focus On in Math session. My name is Pam Overmeyer. I am a special education consultant with the training and consultation team at IU 13. And joining me today is...
I'm Christina Fulton. I'm a teaching and learning consultant in the STEM area at IU 13 with a background in math and computer science instruction, in particular in the secondary levels.
So this session is part of a series of webinars that Lancaster Lebanon IU 13 is facilitating to provide responsive, high quality, focused professional learning experiences that highlight practical and actionable strategies for accelerated learning. The topics and content within this virtual professional learning series were developed as a result of the feedback and supports requested by IU 13 member school districts. Evolving research and data on pandemic recovery, Pennsylvania Department of Education guidance, and statewide PAIU network expertise. There are 4 components within the Pennsylvania Department of Education's Accelerated Learning Framework, and we're going to take a look at a few of those and talk specifically about one today. High quality academics. Again, the purpose of this component is to define the instructional changes needed and foster a culture of data-informed decision-making to ensure every learner has access to the instructional strategies, materials, and supports needed to successfully engage with and master grade level content. The second one is supportive learning environments. The purpose of this component is to ensure that we are providing a safe and inclusive space for learning, forming positive and supportive relationships, and supporting learners and staff to mentally and socially recover. The third one, healthy systems conditions. This is the healthy systems component, focuses on engaging a diverse group of stakeholders within their education community to gain a deeper understanding of the school system and utilize the continuous improvement process and tools to address systematic needs, including staffing, technology, and scheduling that will create the conditions for accelerated learning. And then the fourth one, systems of scaffolded support. This component provides a continuum of evidence-based academic, behavioral, social, and emotional supports aligned with student needs. Today's webinar topic falls under the systems of scaffold supports component of PD's accelerated learning model. Our goal for today's session is to define fluency and automaticity, determine if current students are fluent or automatic in a math skill, explore strategies and tools to develop additional supports for instruction. And the session's handouts can be found at this link, the tiny URL that is on the slide now. And Christina, you already dropped it into the chat. All right, good job. Thank you very much.
Yeah, that should give you access to like our Google Slides. So then you are able to click on any of the links that we have that are active links and have access to all of our resources.
And as we're going through the session, please don't hesitate. If you have a question, please put that in the chat and we will do our best to keep our eyes on the chat if there are questions that do come up, and we'll continue with the flow. So first, I want to ask you to think about what fluency versus automaticity is. In your own words or in your thoughts, define each of the following. Fluency is ... Automaticity is ... And what we'd like you to do is in the chat, from your definition of fluency, how you've defined it, give a real quick little how you've defined each one of those. And then decide if you feel your students are fluent, or do they have automaticity, or do they have a little bit of both? So go ahead and take the next, let's say 2-3 minutes. Think about that, throw it into the chat, and we'll try to summarize what we're seeing. No one wants to be the first one to throw it into the chat. Here we go. All right, now they're going to start coming in. Okay. Thank you, Laura. You can agree with Laura, or piggyback on it, or maybe even throw in your own interpretation of what you're thinking. And remember, how do you feel your students are? Are they fluent, or do they have automaticity, or do they have a little both? Liz, thank you. Got some great pieces coming in here. Fluency's ability to apply. Heather, thank you. Oops. Stacy, thank you.
These are great
Good.
answers.
Kathleen. Yes, that old magic 3-second rule. Okay, we've got some great pieces rolling in here. Thank you so much. Fluency is how quickly they can answer, and automaticity is those things that students know upon sight. All right, thank you, Greg. Liz, thank you. Kimberly, yes, recall. Now they're coming in. All right. So good pieces within here and how you're looking at these two words because we use them simultaneously. We kind of mix them together sometimes. Sometimes we focus a little bit more on the speed of some of the drills that we do with our students. So this is good to see and hear what you're thinking of and where you're at.
And it's like part of our goal for you today is to be able to look at those words and define those words and then think about what strategies we can use to work with our students on both fluency and automaticity.
So with looking at what you guys have thrown into the chat, let's take a look at the definition of procedural fluency. And this is really looking at the ability to apply procedures and accurately, efficiently, and flexibly. Those three words are so very important with procedural fluency for our students to have accuracy within their math, be efficient within their math, and be flexible thinkers. When looking at the digits and the numbers that they're working with, being able to do that and then transfer those procedures into different problems and contexts. That really becomes the fluency piece within our math versus the fluency within reading. And then there's a link there on the slide, NCTM's position on this. We invite you to take a look at that link. It's additional information on this so that you can look at that on your own time. So one thing to keep in mind is that fluency does not equal fast and accurate. And a lot of times when we're thinking about fluency, we get confused with that with our speed drills and timing things. I know in the progress monitoring world, we do a lot of timed probes in trying to look at how a student is doing. And you have to keep in mind of what those probes are being used for compared to what you're doing with a fluency quiz or assessment. In those probes, we just want to get in, get out, get done quickly. Whereas within looking at the specific skill practice with those fluency probes, again, we just want to capture a quick piece of it. But we need to focus on efficiency when working with students so they are able to use strategic thinking. That's what's important here. When doing this, we work with students to think beyond just getting the answer and looking at the meaning of an operation, looking at recording their answer correctly, and looking back to make sure the answers to the problem make sense and is reasonable. And that's key. When kids finish a problem, whew, they're done, they finish it, they go on to the next one. But if we ask them to look back and ask them if their answer is reasonable or does it make sense, they struggle to answer that. And that's part of the piece where we want them to be able to have both that fluency and automaticity together. And again, NCTM's president's message about this, there's a link that you can take a look at and review on your own. We're going to take a look at a quick video here that kind of gives you that background on automaticity and fluency. We're gonna take a look at that. We'll drop the link into the chat if you're interested in that. It'll also be on the resource page. Are you able to pull that up, Christina?
I'll have to exit the sharing.
Oh, that's fine for the sound.
To get the link.
Oh, okay.
So if you have, you just need to drop the link in, right?
Yes, I will drop the link in. Here is the link. Do you want me to share from my screen? I have it up.
So what do you want to share? Like I think we just need to give them a few minutes to watch on their own and come back together? Or do you want?
We could do that, or we can share it all together on the screen. How about we just do it all together on the screen?
I don't think we can.
We can. Here. Let me. Can you stop sharing on your end?
Yeah.
Let's see if we can try this, guys. Thank you. All right, you should see my screen now, hopefully. Okay. Oh, I don't hear anything.
Interesting. In terms of studying automaticity and fluency, the wonderful graphic that you're looking at right now, it's a little bit faint, but don't worry, it's going to get better in a second. This is an fMRI, okay, functional magnetic resonance imaging. It's basically cross-sections of your brain, and they're looking at brain activity. And this is one of the pioneering studies from 2005 where they were using fMRIs to look at how does the brain change over time as a result of developing automaticity with math facts. Because we have all these things like working memory and all these ideas, but like what's actually happening in terms of functional specialization of your brain? Turns out quite a bit, okay? Now this is the original graphic that they had in that journal article where they're labeling all the brain regions, and if you can sort of see, some of the regions are blue, and some of them are color-coded more like an orangey red, okay? That's a very salient difference. What they were looking at were kids who had, over time, had developed a certain level of fluency and those that did not, that were still using conscious, effortful methods for getting math facts, and they give them tasks involving math facts. And then they scan their brains. And what they're trying to do is look at the average of brain activations and figure out what's different between a kid who's using an effortful method and a kid who has that fluency. So what I did to make it a little bit easier for us non-cognitive scientists is I pulled out some of the colors, okay? So now all you're seeing is the blue, okay? These are the kids who are using effortful methods. And the takeaway here is that in all the cross sections, there's a lot of the brain that's lit up. especially in the prefrontal cortex. So they're using a lot of the kinds of parts of the brain that we'd actually want them using for the more advanced procedure that you're trying to teach them, like adding fractions with unlike denominators. Okay? Once a kid has developed automaticity, that's the part they're using more of the back of the thing because they're just retrieving facts from memory. Now, we of course are educators. We want kids using their brains. We want them using their brains on the right things in our classroom at the time. At a certain point, sure, they're learning the math facts, but very soon thereafter that, we want them to utilize the math facts when they're adding fractions with unlike denominators or something like that. So you can see how when you've got this very precious finite resource and your brain is sort of lit up like a Christmas tree, just with the math fact part of it, what's left for the thing that you're trying to teach, okay? And so Menon in 2010, he was actually one of the people who was part of that 2005 study. You know, to summarize the text up there, what they're basically saying is, if the prefrontal cortex is loaded with just the process of coming up with the math facts, there's a problem. There's a computational load there. So what we have to do is figure out teaching strategies that as quickly as possible through efficient repeated practice get it back so that it's being retrieved from long-term memory. Because they basically look at the brain, and this is going to be a simplification, but it's like a couple of boxes or functional parts, right? Where you have fact retrieval, you have executive control, and you have computation and working memory over here. And if these, the executive control and the computation are consumed with your math fact process, you don't have that finite resource left for the things that you really care about.
I'm going to stop my share and you can go back to sharing, Christina.
Okay. My whole window went away. There it goes.
Okay.
Okay. So I wanted to show you some more, like some resources and some more research on fluency and automaticity. So this comes from the scienceofmath.com. So it's a more recent website that has a lot of misconceptions about math, and then the supporting research that goes with that to correct some of the misconceptions. So with linking conceptual understanding and procedural fluency, there is a common misconception that educators believe that the procedure and mastery of the procedure has to come first or come after mastering the concepts. The concepts should be first, but that's actually false. Teaching the conceptual and the procedural knowledge together actually like support one another and strengthen one another over time. A resource that I go back to a lot besides the Science of Math is also using a lot of NCTM, the National Council of Teachers in Mathematics resources, and their Principles to Action book says that fluency builds from initial exploration and discussion of number concepts to using informal reasoning strategies based on meanings and properties of the operations to the eventual use of general methods as tools in solving problems. Effective math teaching focuses on the development of conceptual understanding and procedural fluency. When those two things are connected to one another, the retention and the application become better and become more connected. It really strengthens those. Being fluent means that students are able to choose flexibly among methods and strategies to be able to solve and explain and be accurate. So it encompasses all of those things. Now, computational fluency is strongly related to number sense. So I also like Jo Boaler as one of my resources. She's a professor at Stanford University, and she started a website, UCubed, and she has a lot of resources on there for teachers to use. She has professional development, as well as a lot of some of articles that she's written or some of her colleagues have written. So I have linked, if you have access to the slides, which I gave you, the article is actually linked, as well as I'm going to see if I can, oh, that's what I was afraid of.
I've placed both of those in the chat.
Thank you. It's hard when I'm sharing my screen in present mode, because when I click on something, it ends up advancing. So this is a resource to be able to use later. I feel like we've packed our time today as we only have 1 hour with a lot of different resources for you. So I wanted to be able to summarize some of the main things about it. And something that if we have time later towards the end that we'd be able to talk about a little bit more, be able to answer some questions. But it's really a great article written by Jo Boaler. She talks about number sense and that memorization without number sense, it makes students more prone to mistakes. And it also makes them less willing to think about numbers and relations and less willing to be able to develop some of that number sense later on. She also goes on to talk about that some students are not as good at memorization as others. I was one of those students. It's part of why I really liked math, is because I didn't have to memorize things. I was able to reason through it and be able to figure it out. And that's what I always wanted for my students as well. Our ability and our willingness to be able to memorize is different. And that's okay. That's something that we should be able to celebrate, are those differences. But it's best with developing fluency to be able to work on numbers on different ways and not just rely on sheer memorization. And she goes on to talk about some different ways to be able to develop the number sense. And that's part of what we wanted to show you next, is to show you some ways to be able to develop that number sense and fluency and automaticity with your students, and to provide you with some resources so that you can leave our session today with some things that you'd be able to use. Some of the things she talks about are number talks. She talks about fact activities. She gives examples within the article of those things, as well as some math cards. I'll show you some brief things as well as some additional resources, but that's part of why I have that article linked, and something that you might want to consider exploring later, or sharing with some of the other teachers that you work with. So as we work towards those resources that we have for you, my first question is, if we look at the problem 24 plus 9, doesn't matter how our students get to that answer. So my student that's on the left might say that 24 plus 9, to calculate that, I'm going to do 24 plus 10, because adding 10 is easy for me to do in my head. That's 34, but I need to make up for the difference between the 9 and 10, and I would subtract 1 to get 33. Another student might not like that. That might be difficult for them to make up the difference. So they might start at 24 and count up to numbers that are comfortable to them. So they might break up the 9 and say 24 plus 6 is 30. And I need to get 3 more to get to that 9. So 24 plus 6 is 30, plus the 3 more is 33. Is one more correct than the other? Doesn't matter how they got there. They didn't just necessarily have to know the fact, but they were able to quickly and efficiently be able to get to the answer. So being able to think about numbers flexibly is helpful. Here's another example. Oh, you got it to work, Pam. How cool is that? So let's look at 8 plus 9. 8 plus 9, some students might say, hey, 17, I know that it's a cold fact. I have that automaticity. I can answer that really quickly. But for other students, they might need to approach that in a different way. So we could do that through a number talk. And it's appropriate for an answer for us to put up the problem 8 plus 9 and ask students to tell us how they got the answer and to be able to explain it. So just saying 17, I know a cold is a great answer. Saying that I'm going to round up both numbers and adjust. I'm going to round up 8 and 9 and round them to 10. So I'm getting 20, and I'm going to adjust for the difference. I might round up just one of the numbers. I'm going to add 1 to the 9, subtract 1 from the 8 to try to make things a little bit more balanced in my head. I might say 8 plus 10 equals 18 minus the 1. That's usually my method. That's my go-to. I can decompose. I can use doubles. My son is a 4th grader, and he uses the idea of doubles a lot in the way he is flexible and trying to figure out some of his math facts. That's something that was really brought through his curriculum. So some of those are starters for ways that you can use a number talk within your classroom. Number talks can be used in elementary school as well as middle school. I've been reading some articles and some research on using number talks all the way up through Algebra 2. Number talks can build fluency and automaticity. A number talk is a brief activity that is designed to support students' mathematical sense making and promote their flexible thinking. So as we have time to explore resources a little bit later, both of these on the right-hand side are linked for some different resources related to number talks. So those are our two pieces for you. Some other ideas and resources for building fluency and automaticity is something called clothesline math. I have it again. So these pictures are all active links. So I'm giving you a preview of what it looks like, and then you can click on it to be able to access everything that's within it. Clothesline math is a way to be able to look at numbers in a different way, and it can be a way to be collaborative or have your students work together with numbers. Sometimes involves ordering some numbers, sometimes some operations within numbers, all using a clothesline. So resources that we can pull together really quickly. For the Desmos classroom activities, I linked the teacher.desmos website, not specific activities, but just the teacher.desmos activities in general. From there, you can search different topics to be able to provide your students some explorations and some ways to be able to look at multiple representations of some of our math problems. And then Pam, do you want to share a little bit about the incremental rehearsal?
Absolutely. So incremental rehearsal is just that. You're going to rehearse increments of information. And we're going to use flashcards with this. And we usually call, those drill and kill moments, where we have to drill them and we kill their enthusiasm of learning. However, I did just hear, and I forget the presenter's name, they said drill and thrill. And I really liked that instead of drill and kill, because it is thrilling that once they finally get that fact that they just can't hold on to, they're doing that and rehearsing that in incremental rehearsal. There is a video link to this as Christina created the slides. She linked the video to it. It's under the work of Dr. Matthew Burns. And basically you go through known and unknown facts. You have a pile of 10 that you then pull, 9 of them being known facts, 1 of them being an unknown fact. That unknown fact goes in the front and you incrementally rehearse that. If you watch the video, it will give you an idea of how you go back and forth with using the cards. But I encourage you to do the drill and thrill with your students with using the incremental rehearsal.
Another way yet to be able to build some fluency is to look at numbers of the day. This works particularly well in, at least for the experience that I've had this year doing some instructional coaching in an elementary school. This has been really successful in like the K through 3 grades. And then the resources that I have here are a lot of free resources and templates that you can use. So none of them are paid, none of them are subscription, they're all templates. And then one that I created, I'm gonna see if I can click on it and still get back to my screen. So I wrote it and then set it up so it makes a copy for you. That way we don't have to worry about one another going through and making edits, that you have your own copy so you can feel free to make a copy of it, change the numbers around. But it's a way to be able to look at relationships of numbers and either represented in different ways or related to other things. So this was created for, if I remember right, this was created and used within 3rd grade. So it was to look at the number 521, some vocabulary, odd and even, some rounding, some addition and subtraction. So trying to look at some quick facts with it, doing some comparison between this number and another number, expanding it and looking at place value. So 520 and ones, some skip counting, looking at hundreds, tens, and ones in a place value chart, being able to represent using base 10. So numbers of the day can look a lot of different ways, which is why there are so many different resources that I have linked here. I don't know if I can get that to be full screen again. So I'm going to show it this way so I can see it, but I have 4 different places. So the one is the one that I made, and that's what I showed you, but the templates, depending on what grade level and what your objectives are, can look very different. So that's why I have several resources of free templates for you. This is one of the resources that I pulled from the U Cubed, the Joe Bowler article that I talked about earlier. They're called math cards, so not a really fancy name, but they're like flashcards, but they take the memorization piece away and let students be able to group cards in different ways. So these 6 cards are cards I would all group together because they all represent 36. So being able to recognize that 9 times 4 is the same as 4 times 9, I can represent it using dice. I can also represent it using dominoes. I can represent it in a drawing. I know that its result is 36. So it's like flashcards, but with multiple representations. So
Okay.
say, go
Sorry.
ahead.
You were on a roll.
Yeah, I was. I love resources. I like providing free things.
It's all good stuff. So absolutely, exactly what Christina said, all that we've put together and presented and shared with you, hopefully are at your fingertips now. But we want you to just kind of reflect and think about some of the things that we talked about. Maybe you still have some questions. So what is a takeaway from today, and maybe a question that you still have regarding this topic? Start throwing those into the chat and we'll watch as that explodes here. We're curious as to what your takeaway is today. And then if you have any other questions that are still at the top of your mind, just throw those in the chat. Haha. Jeff, do you still want that defined, or is that what your takeaway is? One word answer for each. Okay. I'm thinking about that one.
So the word that comes to mind when I think of fluency is flexible. What do you think?
I like that. I like that. I like that a lot. Fluency is flexible, because fluency needs to be very flexible in your understanding. And automaticity to me is automatic. I don't have to think, it comes right out. It's automatic. But with fluency, you're flexible, you're thinking of it in several different ways. So fluency, flexible, automaticity, automatic. What are some other takeaways and other questions you still have?
Yeah, I felt like numbers of the day is something that could be time consuming as well. If your students use Google Classroom, these are things that can be made as a Google slide. I've also seen them as pixel arts. I have some free resources for that if that's something that you're interested in. Please feel free to like hang on afterwards and we can chat, or I can try to get you some resources, or you can email me. But being able to make those digital so that students can, like, I like the pixel arts a lot because students know whether their answers are right or wrong, and they have the mystery of trying to figure out what the picture is. Can work pretty nicely and can continue from day to day if they're just doing parts. That way they don't have to do it as a full day. It could also be something that is extra time. But like you said, I think once a week is probably good unless you need to work on it with a particular student. The number talks, the research on number talks shows that if you can do those like 3 times a week, that being more consistent about those is helpful.
And the word time is a 4-letter word. Definitely something that we get caught up in within our daily day-to-day tasks, and some of the pieces that we have that our districts share with us as to a time frame of where we need to teach concepts. However, if you can convince the powers that be that spending a little bit more time here will gain you time later, what research has found is that that does happen, that you spend a little bit of time up front, and then as the kids get deeper into the concept, then that time is not taken away to reteach what should be foundational. Rich, that's a great question. research-based strategies develop automaticity better than others. I think it kind of goes, and Christina, if you have something better, but I think it kind of goes with the student, because we have a variety of strategies and things to use with students, but they don't always all work for all. That's why we have a variety to choose from.
I also think it depends, like I would like to look into that more. Very honestly, I think that would be a great thing for me to research and read about more. But one of the first responses that I had when I read about what you said about research-based strategies is the student on grade level, or are they not on grade level? So is this something where we're trying to really accelerate their learning to bring them up to grade level, or are they performing where they're expected? Because I think that the strategies that you would use there would differ, but I'd like to look into that more.
Stacy's looking for new ways to practice with the facts to make a more normal routine. Absolutely. Laura, I like how you kind of pulled that together with your understanding of fluency and automaticity. That more automatic in their learning, but not just state the facts, ma'am. They need to be a little bit deeper in their understanding. And that's where we're trying to grow with kids being more flexible within their thought process. It's not just, here's the problem, compute it, give me an answer. It's, here's the problem, understand it, compute it, follow up with, does this make sense? Fact fluency is on our report cards. What would be an accurate measurement for this for primary grades, and how do we avoid timing aspect? Good question. And it isn't an important measurement, because you're looking at what skills they have and don't have, to then be able to base what additional supports that you will need to continue to provide access to the content, the general ed content for all students. The timing aspect, again, I told you time was a 4-letter word. It is hard to get away from the timing aspect, because that 3-second rule of, do they have it or not? Is it in the front, or do they have to go back in the back to retrieve it to bring it forward? If they have to do that, especially if we're looking at like multiplication, they're not looking at as 3 times 3 is 9. They're looking at that as 3 times 3, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. And they're trying they're trying their own strategy to remember it. They're going to be accurate, but they just don't have it saved so that they can bring it up quickly. So it is important to be doing that and working with students within that piece. So the timing piece is just to give you that component that says what report cards don't show you is the other side to that coin. Is, we can't give you a little anecdotal piece there that says Pam still is unable to answer some of these questions within 3 seconds. However, she has added 5 new fact families within the last week. I wish we could do more of that anecdotal piece within our IEPs, that it does show that there is some growth there, but maybe that's more in your progress reports or things that go home. Oops. It is hard to see these. Looking at, I don't believe automaticity is addressed explicitly, but it appears to be assumed as a requirement when considering grade math. Absolutely. Laura shared about Pam Harris and her resources regarding problem strings.
I'm reading a book by Pam Harris right now about fluency just in general. It's a very interesting book, especially as a secondary teacher starting to get more experience in elementary. I'm really enjoying the book. I think she's fantastic. Her idea of problem strings can be used within the number talks, and some authors and researchers that use number talks and research on the idea of number talks use problem strings within that. So they only look at those for like 5 to 15 minutes. I like those a lot.
Kimberly, you bring up that you're working with students that are not on grade level and would like these resources to work on the focus of fluency and automaticity, but find they're so far behind and are caught in those effortful methods. And it's very important that those students that are grade levels behind 1, 2, 3 or more, that we find out, well, what's the other underlying culprit there? What's going on? What early numeracy piece do they might not have within their skills looking at the math that is in front of them? And that takes a little bit more digging into maybe more kinds of diagnostic assessments, or looking at some of the assessments that you use within your district to see what skills they can or cannot do. Most of the time it goes down very much deeper into even place value and then quantity identification, and just really understanding what that number value means. And we don't look at that as being the problem for the student to move into some of the other problems, but those are kind of the gatekeepers that to lead into being able to compose and decompose and then bring together or take apart numbers. So we really have to, what I like to do is, like pull apart their math and look at what they're doing and understanding and see what skills they have to be able to focus then on what I need to amp up in support for those students. Oh yeah, Dr. Ricamini. Can't go wrong with anything Ricamini. Anything Ricamini, I'm all for it. Continuing to look through here. Yes, Patton does have some great resources on there. Thank you for including that on there.
Pam, I'm wondering if we want to do the accelerated learning slides and then stop the recording and have some time to be able to chat or answer questions. And like, I love this sharing of resources.
Absolutely. Okay.
Should I advance the slide here?
Go ahead. Yes. So again, for more information regarding accelerated learning, the website here, and I think, Christine, are you going to take us there? Or are we not going there? I didn't.
I can. Here we go.
So again, on the website, and that link is live when you take on the notes. You can go in there for more information, for more sessions. Please share the link with friends, family, to enjoy and take part in these sessions that have been created for you to move forward. And as we start to wind down here this evening, as a reminder, IU13 will award Act 48 credit to registered participants who actively participate for the entire duration of the live webinar. In order to receive Act 48 credit, participants must attend the full 1-hour webinar and complete the Act 48 evaluation in Frontline. So you will need to go on Frontline to do so. Again, as Christina mentioned earlier, within that tiny URL, as we started out the session with, there's additional resources and references from our session that can be found at this link.
Yeah, so the link given earlier was the link to the whole slide deck, and things are actively linked throughout. But if you're looking for some of our resources and references, this is a Google Doc. I'm actually going to go through and try later to add some of the things that I found and that you guys have supplied in the chat. I'm going to try to add that to a different section. Since this is a live document, you'll still be able to have access to that. But I thought it would be nice to be able to include that there. So you can look for that coming.
Oh, that's perfect. So stay tuned. And there are several accelerated learning resources available from PDE, and a few of which are linked on this slide. And again, that's in that slide deck that you're more than welcome to take a look at. And then again, if you have additional questions, please feel free to contact either of us. Our information and our contact information is here on the slide, in the slide deck. And thank you for your interest in the topic of fluency versus automaticity in math. We're going to stop recording and kind of do a share out.